Let's talk about genetic genealogy. Genetic genealogy is fascinating to me. But first, as we get started, we got to ask the question, what in the world is genetic genealogy anyways? Here's a definition from Family Tree DNA, which was the first company to make DNA testing available to the public. They were the first to spearhead that. So they define it this way: it's the use of DNA testing to determine relationships between individuals, find genetic matches, and discover one's ancestry. Now, what's so fascinating about genetic genealogy is at the very beginning of its existence. So as you are participating in genetic genealogy, you are blazing the trail for this specific science. It's really only been in existence since the understanding of DNA as it relates to criminology in the late 90s, and then through genealogy up into the early 21st century. So as you are participating in genetic genealogy, you are making science happen, and you're on the burgeoning field of that. So it's really exciting because we're learning a lot of new stuff all the time as more and more people test their DNA. So you can see the field of genetic genealogy has grown exponentially over the past few years as they've made testing more available to people. Genetic genealogy really kicked off on 2014. So it's really only been around for 5 years. And in that time, Ancestry.com, which is the leading DNA company as far as one specific type of test is concerned, now has over 15 million people who have tested their DNA in their database. That's not including all the databases, but that's just their database alone. So it's gone in 5 years up to 15 million people for Ancestry.com. Now here's what you need to know about tests. There are 3 different types of DNA tests: mitochondrial, autosomal, and Y-DNA test. Now people ask all the time, what kind of test should I take? And the answer to that question is by answering these questions here. What are you trying to accomplish? What are you trying to learn? What do you want to know? That's going to help you determine what type of test you should take. So we'll talk about the differences here, but as you're thinking, maybe you've already tested and you got sucked in from some of the marketing to test, but you weren't really sure why you're doing that, but you just tested anyway, and I'm glad that you did. But you want to ask yourself, what am I trying to find out? Now, I put this bottom bullet up here at the beginning to put a caveat in here about genetic genealogy. It's true about traditional genealogy as well, but this is more shocking. But traditional genealogy, as you dig, you're going to find out stuff that you don't want to find out. And so you got to be aware of that as you go in. Now, as you test genetic genealogy, you could find something out that you totally did not know, like this is not my dad, or this is not my mom, which is commonly known as an NPE, a non-paternal event. It's so common that they coined this phrase, okay? So a non-paternal event is where you get your DNA results back and your mom doesn't match you, your dad doesn't match you, and there's been a family secret for a long time. And it can really be a major paradigm shift and tear some people up. So you got to be aware of that before you test, that you could, and all of the DNA testing companies say, you may learn something that you don't want to know, as a disclaimer before you take the test. So just be aware of that. You may not want to take the test. So be aware of non-paternal events as you consider doing genetic genealogy. Now show of hands, who has done any kind of DNA test at any kind of company? 1, 2, 3, 4, 5, 6. Only 6. 6. Good. We should have everybody in here test, unless you got some kind of information you don't want to get out there. But you should test just for fun. All right, I hope I didn't scare you away too much, but I make that serious caveat. All right, let's talk about the 3 types of DNA tests briefly, and I'm going to spend the majority of our time talking about Y-DNA. Mitochondrial DNA, we're only going to use one slide here to talk about it. Mitochondrial DNA traces the mother's mother back along the mother's line. Mitochondrial DNA is passed from the mother to all of her children, but a son does not pass on mitochondrial DNA. So if you're interested about tracing your mother, on back to Eve, then you take a mitochondrial DNA test. And you can take a mitochondrial DNA test at Family Tree DNA. What you will find is that just like with the more common DNA tests, you'll get matches of people, but look how many generations it goes back. 52 or more. All right, so this is going ancient DNA that you have received from your mother, and so on and so forth. Now, why is that important? Scientists look at these DNA results to trace ancestral migration routes of your direct maternal line stretching back thousands of years, right? So where did your mother's family come from? There's a way to trace as they unearth ancient skeletons. They take DNA results from them, and guess what? They match people who are alive today. So they're able to trace the migration routes of family groups by doing this type of DNA test. So that's all you need to know about mitochondrial DNA, mothers, all the way back. Autosomal DNA is the most common type of DNA test. Ancestry.com test. Who's taken the Ancestry.com test? 1, 2, just 3. Okay. This is an autosomal test, Ancestry.com. What is autosomal DNA? Autosomal DNA traces DNA from all branches of your family going back only about 6 to 8 generations. Now, why can it only go back that far, 6 to 8 generations? If you're here, you got 50% of your DNA from your dad, you got 50% of your DNA from your mom. You got 25% of your DNA here, 12 and a half here, and it keeps dividing half, till basically you don't have any DNA past 8th generation as far as autosomal DNA is concerned. So autosomal tests only can take you back a certain distance before you have matches. Now here's something interesting about autosomal DNA. Most fourth cousins don't share autosomal DNA. You won't show up as a match on an autosomal DNA test. So there's a lot of fourth cousins in the family reunion here this weekend. And so if I had only done a DNA test, I wouldn't have been able to trace many of the people who are here. But through traditional genealogy, I was able to do that. So when you take an autosomal DNA test, you're only going back 6 to 8 generations. But that's because it pulls DNA from all branches of the family, right? Mitochondrial is only tracing your mother. But here you can trace all lines of your family, so that's why it's really helpful. You want to trace all different branches of your family, you take autosomal tests because you're going to find people from all the different branches of the family that are listed there. Okay, before I give you this little technique here, any questions about what autosomal DNA is? If you take an autosomal DNA test, this is an excellent way to maximize the test so that you don't have to retest in different ways, in different ponds. You can fish in multiple ponds using one DNA test. All right? And so here's how you do it. You start at testing Ancestry.com. That should be the first test that you take, Ancestry.com. And the reason is, number one, Ancestry.com has the biggest pond to fish in, right? Over 15 million fish are in there for you to connect with. But what you can do at Ancestry.com is then download the raw DNA data. Now, it's just a code of millions and millions, strings and millions of letters in a row. So it's not going to make sense to you if you look at it, but the computers get it. So you download your raw DNA data from Ancestry.com. All you got to do in order to do that is up here in this corner next to your sign-in name, there's a settings button. Go to settings, and then you'll find an area to go to DNA data, and you go in there to download your raw DNA data. Now when you do that, you have the file on your computer. You can transfer that file first to familytreedna.com for free. All right? Familytreedna.com right now is the 4th largest DNA pond to fish in for autosomal DNA. Okay? So you can upload it here for free, create an account, upload your DNA, and you'll get to fish in that pond. Now you got to pay to get extra access to different features that they might offer, like what percent German are you? You got to pay extra for that kind of thing. But as far as the matches are concerned, you can see who you match, right? So you can upload it to familytreedna.com. The second place you want to upload it is called jedmatch.com. This name, Jed, that's a name for an online family tree file. So like I have the Craig family tree on Ancestry.com. I can download that entire tree into a file, and it's called a Jed file. So JedMatch is a non-profit volunteer site that was started by a couple of guys within the last 10 years, where people can upload their DNA from various testing sites to compare against each other. So if I tested at Ancestry and my brother tested at 23andMe, we can't look at how we connect to each other. But we can both upload our results to JedMatch, and then we can see how we compare against each other. So it's a great place to see how you can fish in this pond. So you download the raw DNA, you upload it to Family Tree DNA, upload it to JedMatch. Sometimes this third DNA company called MyHeritage, this is the third largest autosomal DNA company, sometimes they open up a window where they allow you to upload it for free into their database. I caught one of those windows, so I threw my fishing pole into that pond as well. And so you want to upload it to MyHeritage as well. So see, your pond's getting real big, right? You got lots of ponds to fish in as you do this. Finally, Living DNA is a new DNA company that's based in Great Britain. Okay, and so they just opened up in the last couple of years to try to help target the Great Britain countries, Scotland, Ireland, and England and Wales. Same with them, sometimes they open up a window where you can upload yours for free there. Not all the time, but you can maybe get in there. I've not been able to get in livingdna.com. But that's all free. If you can download your raw DNA data, you can get into all these things for free at some point. Number 4, 23andMe doesn't allow you to do any of this. So if you want to test at 23andMe, you've got to buy a kit from them. So maximize your autosomal test results. Ancestry first, download the data, upload it to these sites, and then if you want to keep going, test at 23andMe last. Mike?
Yeah, is there any group that has all the different sites and compares accuracy to one another to see if there's some variations between the information they provide?
So, all right, good question. Let me see what I got next here. Okay, good question. When you see a commercial on TV for testing DNA, what are they telling you you're going to find out?
Where you come from.
What percentage you are of this or that, right? That's the marketing technique to get people to test. That information is not very helpful unless you just have no idea where any of your ancestors come from. And what the variation that you will see among sites is in that area of the test, because this is how they do that. Let's say they want to test what Scottish DNA is. They go to Scotland and they find a pool of people who have documented history in Scotland going back as far as like 300 years or 400 years or something like that. And they test those people for DNA, and they come up with what a conglomeration of what Scottish DNA is. And however close you match that group of people, that's what percentage of DNA you have based on that pool of people from that country, right? Well, they're still refining that science, right? So it's not precise. So even I tested with Ancestry DNA in 2014, I think, and they have refined the algorithm multiple times since then, so that my results have changed 2 or 3 times since I've been in there. Because that pool of people, they're finding different, better people to test and all that kind of stuff. It's not an exact science. That's the way they get people to buy the test and get into the pool. So it's helpful if maybe you want to find out if you have some Indian DNA or something like that in your family. That'll show up on there if it's within the last 6 to 8 generations. If it's further back than that, it's probably not going to show up. So the variation will be in that part of the DNA test, but not in the matching of people.
Okay, so if you did a DNA result through more than one site, that would match up perfectly?
No, it won't, because they all use different pools of people. So family tree DNA doesn't use the same exact group of people that Ancestry does, and 23andMe doesn't use the same group of people that family tree or the Ancestry does. So they all got their own group of people that they test in those various countries, and they're going to have different DNA to a certain degree.
Right, so
So to get to your other question about is there a way to compare those? The answer is
not
yes.
just location, but the DNA, the very precise DNA information,
Like this raw DNA data?
that doesn't have variations from one company to the next.
Correct, that does not have variation. Yeah, that's right. There's no variation in the raw DNA data, and you may see why in a second here, but there is variation in the percentages of nationalities that you have. Does that make sense?
So to get a true diagnosis of really who I am, where I came from, bloodline,
Yeah.
what's the best one to go to?
Well, it depends on what you're exactly trying to find out. So how do you define or determine where you come from? Your father's 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 line, your mother's 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 line, your father's mother's father's mother's... Which line are you talking about? Now, you can find out your percentages through traditional genealogy without doing a DNA test, and here's how you do it. You go back... If you go back to your, let's see, here we are, 50, 25, 12 and a half, what is that, 6 1/4? If you get to 6 1/4, which is your dad, grandpa, great-grandpa, second great-grandparents, if you can fill in all of your second great-grandparents across that line and just look at their surnames, you'll know this percentage is from England, this percentage is from Scotland, this percentage is from Mexico, this percentage is from Germany. So I can do that. You can do that on, well, I've done it on my family. You can get back to second great-grandfather. It's not too bad. Some, you might miss one or two, but just by looking at the surnames of your second great-grandparents, you'll be able to come up with a basic percentage of, okay, that's how much DNA I have from these locations. Good question.
Sorry.
No, keep going.
How much of a percentage does it make you a part of a certain group?
Okay, good question. I think I know what you're asking. When you get a percentage map that pops up, it'll say you're 90% English, 5% Scottish, and 1% Iberian Peninsula, or something like that, right? You got all these trace amounts of DNA that are like 1, 2, or 3%. Anything that's 3% or below, throw it in the garbage. All right? That's just noise from the results. But if anything is 3% or lower, you shouldn't trust it on your this percentage. That's autosomal DNA. You feel like you understand autosomal DNA now? Okay? All right? No? It's okay if you don't?
Jonathan, quick
Yeah.
question before we move on. So if you were going, based on your experience, off a recommendation for a DNA test, it would probably not be 23andMe.
I would not start there. And the reason is, well, first you got to ask yourself a question, what are you trying to find out? By answering that question, that's going to guide you where you want to go. But I wouldn't start with 23andMe because it's a smaller pond to start in. If you start with Ancestry, that's where you get the biggest bang for your buck. Now, that doesn't mean 23andMe is no good. That's a great testing point. Yeah, exactly. Because we have relatives that have tested at 23andMe that have not tested anywhere else. So I'm not going to find them unless I also test there. So you also want to test there. Unless they've uploaded to GenMatch, right? They can upload a GenMatch and find them there.
23andMe won't upload to GenMatch.
Yes, it will.
Oh, it will?
Yeah. So 23andMe can go to GenMatch, but it can't go to any of the others. Yeah, thank you for clarifying that. Okay, here we go. Y-DNA. You may have seen this graphic over here on the little table. But Y-DNA goes father, 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 father's line. It's only passed from father to son, father to son. Women don't have Y-DNA. Men have an X and a Y chromosome. Women have 2 X's. Okay? So Y-DNA is specific only to males. Father to son, father to son, father to son. So, women, you can't take a Y-DNA test. So this traces the direct paternal line, fathers, 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 on back. Same thing, it's going to provide a list of matches who match your Y-DNA. Look here, 25 generations. And actually it goes further back than 25, but genealogically, that doesn't help you because there's no records going back 25 generations, right? The DNA does, but the records don't. And as you get back really far in time, they're tracing the migration routes of people across Europe, for example. So our ancestors, where did they come and how did they get to Scotland? That's what they're kind of trying to figure out as they look at these groups. So this is an important word to learn, haplogroup, right here. And the way to think about a haplogroup is it's like your great-great 10th great-grandfather's DNA signature. And that was passed to a group of people. That makes a haplogroup. It's like a big family. They all have the same DNA signature. All right, this might look kind of scary to you, but don't let it scare you. This is what you need to know with Y-DNA. There are two types of mutations that you look at in Y-DNA. The first is called an STR, right here, or a short tandem repeat, STR. So in the DNA double helix, you have a series of nucleotide bases, guanine, cytosine, adenine, and thymine. They're abbreviated GCAT. And these bond together to create this ladder of DNA, right? So G bonds to C. See, here's G bonding to C. And A bonds to T. Here's A bonding to T. All right? Now you will have a series of these bonding pairs repeat each other in your DNA. So here's a short tandem repeat that goes TAC, TAC, TAC. See that? That's called a short tandem repeat. So you would get a number assigned to this short tandem repeat depending on how many times it repeats. This one repeats 3 times. So on this section of your DNA that they're looking at, this STR, you would get assigned a number 3. Now, Mike's DNA might repeat 3 times, but then when I'm born, there's a DNA mutation that kicks this to 4 repeats. And now I have a 4 assigned in that number, and he's got a 3. And by tracing those mutations throughout the generations, that's how you determine who comes from what branch and so on back. So one part of the Y-DNA test, the basic Y-DNA test, is an STR DNA test, okay? And we'll talk about this in a little bit more detail. Now, if you want to get really advanced, you'll start looking at what are called SNPs. Single nucleotide polymorphisms. Just call them SNP. You don't need to know that long name right there. But a SNP is a different type of DNA mutation where instead of a repeat going down the line this way, you have a mess up in the way that these are paired together. Okay, so instead of an A here, you might have a C. Or where there's supposed to be a T here, all of a sudden there's a G. And that's called a SNP. There's been a single nucleotide polymorphism, a substitution for what should be there. There's a different nucleotide base that shows up there. Does that make sense? So instead of a T, there might be a G. Instead of an A, there might be a C or something like that. Something goofs up and the DNA mutates there. So in a more advanced Y-DNA test, they look at these SNPs, which are more helpful than STRs. They both help in certain ways. SNPs are more helpful in some specific ways. So, for example, on family, let me say this, Haplotree DNA is the only website you can go to do a Y-DNA test, STR or SNP. They are also the only one you can go to do mitochondrial DNA. 23andMe will give you a Y haplogroup and a mitochondrial haplogroup, but it's just a best guess. They're not specializing in that. They specialize in the autosomal part, but they also try to give you a general haplogroup for both Y and mitochondrial. But for the real deal, Haplotree DNA is the only one that does this type of test. So, in Y-DNA, the reason Y-DNA is really important is because it follows the same pattern as the surname. So just like the father passes genes to the son, Y-DNA to the son, he also passes his surname to the son. So that helps you trace your surname back really far because it has followed the same pattern as the Y-DNA. Does that make sense? So in familytree.com, there's all kinds of surname projects that you can join. And obviously you want to join your surname project. So there's a Craig Surname Project at familytreedna.com. There are also geographical projects, so people who are from Scotland, they all join a project to compare DNA. So there's all kinds of these different projects that you can join, and you can join as many as you want on familytree.com. Now, in the Craig Surname Project, this is looking at STRs, short tandem repeats, all right? And you see all these numbers here. These are different spots on the Y DNA chromosome where they look for those repeating patterns. And so, we'll take a look here at this Craig lineage 1. You've got the name of the tester, the most distant ancestor name that they know. They have to put that in. So you can see these people don't know it or left it blank, which is not helpful. So if you do this test, please put it in. So they can see this guy, he knows he goes back to 1737 in Williamsburg, Virginia. The country of origin, where this person came from, he knows it's Ireland. They don't know. So what can they assume about where their country of origin is? Ireland. They've connected with some relative who knows something more than they do about their ancestry. And so now, because of their DNA, they know, okay, this James Craig, born in Williamsburg, Virginia, he must have come from Ireland, or his ancestors came from Ireland. So you got the country of origin next. Now they've got to put that in, so it could be wrong if they don't know what they're talking about. So you got to be sure you keep some healthy skepticism about what you see on here. The haplogroup is assigned by the DNA testing company. So you can see these are R's up here, and then they got extra numbers and letters afterwards, R. R M269 is the most common haplogroup in the Western Atlantic. Okay, so there are bunches and bunches of R M269s. Here you can see some E's, and then on down, and what are we? IM223, okay, right? Now, in the Craig Surname Project, there are 20 different lineages of Craigs, meaning they're unrelated. These are unrelated groups of people who have the surname Craig, and we know they're unrelated because they have a totally different haplogroup. The place where R's and E's connect is way back there. Noah's sons, one was a R, one was a E, or something like that. It's way back there, right? So this is way back there. And guess what? How many I lineages do you think there are in the surname group? 1. We're the only Craigs that have an I haplogroup. So if somebody tests and they don't have an I, they're not our Craigs. They're somebody else's Craigs. Or a non-paternal event has happened. Right? That's what happened. So a non-paternal event, like we talked about, that can happen in any number of ways, right? Somebody's been unfaithful, or maybe, it could be something like a sexual assault, or it could be an adoption, or it could be a switch at birth, or there's any number of things that could happen that cause an NP. It's not always infidelity or something like that. There's a variety of things that could have happened. But beware, if you take the test and you don't come up IM223, your Craig dad's not your Craig dad. All right, so just beware of that. Questions? Questions about this idea for a surname project. Now what this helps with is determining two things, patterns and then origins. So we'll talk about this pattern here. I've got this sheet on that table if you want to get close to it, but this might look really scary too, but the point is just look at the pretty colors. That's what's important here, is to look at the pretty colors. Because what we have is beginning to see how different branches of the family have mutations. So take a look here. This is the I group, our I group from the Craig DNA project. Duncan Craig, right here, tested second. I tested first. There's nobody in my group. It was just me. Duncan Craig from our family tested second. He lives in New Zealand. And his ancestor was born in Ireland and died in England. And all of the ancestors from this branch still live in England, except for him, he lives over in New Zealand. So I've found these folks on Facebook, and some of them are my friends on Facebook, and we have at least one in the Craig family group who's over in Lancashire, England. That's not where they originate from, but that's where they migrated to, out of Scotland to Ireland, over to England, and then some all the way over to New Zealand. So we don't know the exact relationship here, but we'll talk about that in a little bit. So here I am, next, and then we've got 4 men, including myself, who have tested from our branch of the Craigs, right? We got me, Bill Craig, who is not here right now, but he's from the James Craig clan. So he's a 3rd cousin once removed for me. We got Mark Craig, who is from the Charles Craig clan. He's a 2nd cousin once removed from me. And then we got my father, Michael Craig, here. He is my father, so there it is. I-223, not a non-paternal event. And so why this is helpful is because here we have 3rd, 2nd, father, son. So we get a pretty broad sweep of the DNA across the family tree. And what you will notice on this first page is that all the men from our family have a STR of 14 on this specific part of the DNA. 14. Now look, Duncan Craig has a 15 here. Most likely, Duncan is a 7th or 8th cousin. 7th or 8th cousin. So we've got 4th cousins here. But as far as Craigs are concerned, there are no 5th cousins and there are no 6th cousins that we know of. There are only 7th cousins because of the way the family tree branches out. And probably, he's my father's generation, probably. And I know his age, but you know how some families reproduce faster than others, so there might be an extra generation in there, here or there. He's got a 15 here. Now, the mutation is on our line. We mutated and got a 14 instead of a 15, because look at all these other Craigs here. They all have 15s, so that means the mutation came from, we mutated and dropped off one of those repeats to go to 14 instead of 15, right? So we all share this mutation. If you are in this room, or if you're in this reunion, if you're a part of our family at all, guess what? On DYS 385B, you've got a 14 STR. All right? So that determines what part of the family you would be a part of. If you tested and you had a 15, you're probably part of this branch of the Craig family up there. Does that make sense? Okay, so you see where we're going. Now, when you do a Y-DNA test, they look at a specific number of markers. First, they look at 12 markers here, the first 12. Second, they go to 25 markers. Look at the 25, and look at the pattern here. This is Duncan Craig at the top, and here's our 4 Craig men. And the common number among all these Craigs is 27, so we have the normal number. And here, Duncan mutated, his line mutated at some point, and he has a 28 repeat instead of a 27 repeat. So again, that helps refine what part of the branch of the family you might come from. 25, and then 37. So if you take a Y-DNA test at familytreedna.com, you're going to do a 37 STR test. That's the basic test. They're going to look at 37 points along the Y-DNA and the STRs, the short tandem repeats, to give you a code. So as we look at 37 out for our Craigs and Duncan, we all have 9s here. But look, the actual common one is a 10. So our common ancestor, whoever was a father to Duncan's ancestor and our ancestor, he had a 9 going way back. 1700s, 1600s, most likely in the 1600s or back or further. So these 9s separate us from this other branching of Craigs here because we all are in the same pot as far as this mutation is concerned. All right? Does that make sense as far as the STRs, what they're useful for? They help you identify these patterns so that you know what part of the family you come from. Now here's what a page looks like when you test your Y-DNA at familytreedna.com. One of the pages is about your matches. Now take a look here. This is my page, and I'm at 37 markers here. See this? 37 markers. Now I have tested up to 111 STRs. That's the highest STR test you can take, 111. So you can change this on the menu to see your 111 matches if you want to do that too. But what that does is it just brings you further down in time so you have fewer matches that would match you at that level. But notice here, on my Y DNA matches, there's a Craig, there's Bill, there's Dad, here's Mark. Mark's not here, he left yesterday, but he's a second cousin. And look at this, there's a Watson and a Whitty. So what's going on here? It's not an NPD, just so you know. But if you take this test and they're all Watsons, you're a Watson. You're not a Craig, okay? But there's a couple things you want to look at here. Number one, this genetic distance. Genetic distance means how many mutations separate you from this guy, okay? At 37 markers, we have no differences between these three Craigs here, right? So that means we're closely related, okay? So we got a third cousin once removed, father, and a second cousin once removed. So we're closely related. There's one genetic distance here, so there's one mutation on this chart that separates this William Watson from the rest of us, okay? It's not talking about generations, it's talking about mutations, okay? Now, here's where this is helpful, and this hopefully will make sense to you. Surnames were not used until the 13 and 1400s in our part of the world. So people did not use surnames, and the purpose really for surnames to become used was for taxation purposes. So that as they raised taxes, the government raised taxes, they could keep track of people. So people began to adopt surnames. So what happened at some point in the past, before the usage of surnames, there were a group of brothers, let's say, brother Stephen here and me. We're in Scotland before surnames were being used. And surnames come into use, and for some reason I choose Craig. Craig means a rocky outcropping, so I lived among the rocks up in northeastern Scotland or something like that. So I choose for myself, because it represents my homeland, I choose Jonathan Craig. And so I choose that name. But Stephen chooses the name Whitty for some reason because he's a really funny guy. So he chooses, I am Stephen Whitty. We're brothers, but now we have different surnames. Okay? Because now surnames have come into use. And then those surnames get passed on down his line, and my surname gets passed on down my line. So what this means is that somewhere way back there, we're related to somebody who chose the surname Watson, and we're related to somebody who chose the surname Whitty. But it's way back there before the usage of the surname. Okay? Now this is helpful, you'll see in a second, as to how it can help pinpoint the location of where we come from. Now you'll see in these matches, you've got here, how high have they tested? He's done a Y DNA 37, he's done a 111 STR. The big Y, we'll talk about later, is a SNP test. FF stands for Family Finder, which is Family Tree DNA's Autosomal test. Okay? So I've transferred my ancestry results over to Family Tree DNA, and then I've done the Y DNA up to big Y as well. You got your DNA haplogroup, terminal SNP. You see that should look familiar to you. It's the same thing as Y DNA haplogroup, all the way down to where we are today. And you got your what date did they test and show up on your match list. All right, now this is how this helps. I've got this on this table here too if you want to look at it more closely. But you can now lay out your matches based on the STR tests, and by looking at the surnames, you can determine, where they come from. So at 111 markers, I have one Craig. I have a 4 here because there are 4 of us that have tested. I've got one Craig at 111 that matches me. That's Bill. And we have a genetic distance of 2 at 111 markers. So there are 2 mutations that have taken place between me and Bill since his birth and my birth, down our different lines. Okay? That mutation difference helps us determine how far apart we're related. And then at 111 markers, there's a Whitty at 111 markers that has a genetic difference of 8. So there's 8 mutations that have taken place between his common ancestor and my common ancestor. What that means is we're if we're related within genealogical times, it's so far back there that it's not really helpful to us as far as genealogy is concerned. But for origins, it makes a difference. Okay? Now we go down to the next marker they use is 67 markers. Guess what? We got more matches because people don't test as high because it costs more money to go higher. But at 67, we've got Craig's here. But notice the distance at 67 is smaller. We only have one genetic mutation. There's still only 2 of us at 67. That's Bill and myself. But we've got Watson in here showing up at 4 genetic mutations. We got Whitty, Shimon, English, Simpson, Hogan, and Holloway. So what we do is now we assign these keys to these names. What's the origin of these surnames? Blue represents Scottish surnames. Green represents Irish surnames. Red represents Norman or English surnames. And then if there's no fill-in, I've called it continental surnames, meaning it comes from the continent of Europe, not from the British Isles. Right? So what you'll see is that the names that are fewer genetic distance here shows the more recent origin. The more recent origin. As you go back this way, you're going back in time. And so you begin to see other origins creeping in. So take a look. This is just something interesting here real quick. See this name Shimon and this name Simpson. These names are related to each other. Shimon means son of Simon. Simpson means son of Simon. These Shimons are on the Isle of Man, which is between Ireland and Scotland. And this Simpson, we don't know where he goes back to, but guess what? They have a surname that is related. They come from a common ancestor somewhere back there, because Shimon is the same name as Simpson. It's just been changed a little bit along the way throughout history. So as we move back in history, we see Scotland, Ireland, England starting to creep in. So what's happening is we're tracing the migration route of ancestors here. Now here's 37 and 25 and 12 going back. So we're going back in time here. Scotland, Ireland, England. Now look, as we go way back in time, there's a lot more English names in here. So what does that mean? It means before the Craigs got to Scotland, they came through England, right? They came from the continent. Most likely, we have heard earlier, Danish Vikings probably spread IM-223 across the British Isles. So the Vikings would have come in to England and then up through Scotland and Ireland at the same time. So that's why we see these changes in the surnames going back. Do all these men share a common ancestor? Yeah. Way back there somewhere. Way back there. They all share the same ancestor because these are all IM-223s, right? Way back there. But as we come back in time, we begin to trace the pattern, okay? The Craigs came from Scotland, but it came by way of England, from the Danish Vikings on the continent, because guess what? Look at these names here. See that name, Beaver? That's a German name. And you can see they've done a lot of testing. They have 18 men that have tested. And this name, Paulson, that's a Scandinavian name. Viking, most likely. And so we begin to see these continental names creep in as well. I mean, from the continent, through England, and up into Scotland. All right, last thing we'll talk about is the Big Y SNP test. Everybody remember what a SNP is? I remember what a SNP is, okay? Short tenomer repeats, the STR. SNP is the single nucleotide polymorphism substitution. Let's go look at this real quick. Here it is down here. This is where there's just one little mutation where there's a substitution. So this A, instead of being an A, becomes a C or a T or a G or something like that. So that's what we're looking at here. This is much more of an advanced and precise look at the Y DNA. So when you do your Y DNA test, or Big Y SNP test, you'll get these 3 different things. Named variants, meaning they have named the mutation that has taken place because it's prevalent enough that they give it a name. It's already been witnessed in a large group of people. And so there'll be this long list here of named variants that you have. This goes way down. The other thing you'll get is unnamed variants, meaning that mutation is either specific to you or your father or your grandfather, somebody who has not tested, has not ever found this variant before. So when I first tested a SNP test, I had like 30 unnamed variants, which means the last person who tested on this besides me, there's been 30 mutations since I common ancestor in here. Now when I got billed a test, I have 0 unnamed variants now, because the variants that have taken place in both of us now have been witnessed across multiple people. They named the variants and moved them off of the unnamed variant list. The third thing you'll get is a matching, but this type of matching is not the type of matching like you're looking for with the autosomal test, because what you're trying to get at is a little bit further back in time. So here's what this will look like for you. The SNP test, why did I go for the SNP test? The reason was I hit a brick wall in the family tree at James Craig in 1717. I couldn't get past him. I still haven't been able to get past him to get back to Scotland to know exactly who his dad was. So I thought by testing at these higher Y DNA levels, I'd find another relative who would be from a distant ancestor. And that was Duncan. It actually worked. I found Duncan Craig. And he helped trace back a certain point, but guess what? My tree went back further than his, so I actually helped him out instead of him helping me out. So that's the way it worked, and that's why I went all the way to the SNP test. And what you will find on here is this is one of this big Y test features is called the public haplotree. So this is like a family tree of all men throughout history. And you'll see here are all the different haplogroups at the top here, A through T. I actually have T. And then I click on the I branch, and then under the I you have all these different mutations. And these mutations are moving us further down in time through the family tree, and this is the bottom of this family tree. And here's what happens. When I first tested this SNP test, I was here at IP95. You see there are 4 testers that had landed here. So this is where I was for a while until more people tested. When I tested here, a few months later, a Simpson tested Big Y. And when the Simpson tested, it knocked me all the way down to here. So you can see there's one other tester there, that's the Simpson. So you remember that name from the STRs? Same family. Simpson tested here, so that moves me from, if this is the dad, here's like a son. Get it? So it moved me down. Then, when I got Bill to volunteer for me, we tested and boom, we went down underneath this branch even further. But between this branch and where we are, there are like 20 variants between there that need to be named by other testers as they test, which will create more branches in the family tree between the Simpson and the Craig. So we need other people to test, Simpsons, Craigs, others, Whitties, Watsons. We need all those names to be tested in the SNP SNPs so that we can figure out some refinement here about these branches of the public haplotree. And here you go, IP95, see it here? Then you got IS21625, that's where the Simpson came in. And so here's the dad. Just look at this as a person, this is dad. And here's one son, and here's another son. This son is Simpson, and this is the Craigs right here. So this is where Bill and I sit. And all of these are mutations that have occurred somewhere between dad and all these great-great-great-great-great-great-grandchildren. But as you test more, these go away and more branches pop in. Does that make sense? It's complicated, but it's just like a family tree. Here's grandpa, here's dad, here's a son, here's a son. But it's like we skipped 30 generations in between. So in reality, this is a great-great-grandson. We just don't have all these figured out just yet. And there we are down at the bottom. You see our DNA matches. I have one DNA match here, and that's Bill. And look, here's David Simpson. He's a DNA match. But he's on a different branch, but we still match because we're related back on that common ancestor tree. Now, all these men share a common ancestor way back there, thousands of years back there. But we're trying to refine the family tree as it comes down the Y DNA tree to to figure out where we go. So you can see this little Scotland flag here. That's because I put in that the most distant ancestor that we know of came from Scotland. So if you take a big wide test and you're looking at these, you got to keep in mind these are user inputs, which may be mistakes. So you can't always trust these little things here. All right, that gets us to the end.